In this video, we are going to explore the way that Live interacts with your computer and take an overview of some important steps you can take to optimize your experience of using the program. Before you begin optimizing Live for your computer, make sure your copy of Live is up to date. Next, ensure that everything outside of the program is up to date as well. Check that your computer's operating system is supported by the version of Live you are using. Make sure your audio interface's drivers are up to date. On Windows, make sure your graphic card's drivers are up to date and that you have the high performance power plan engaged in your system preferences for power consumption. Also ensure that your third-party VST and audio unit plugins are up to date and supported by your computer's operating system. In the top right of Live's user interface, you will find Live's CPU meter. This readout will show you how much of your computer's processing power has been allocated to Live's audio processing tasks. Note that the CPU meter takes into account only the load from processing audio, not other tasks the computer performs. For example, managing Live's user interface, displaying plugin windows, or displaying a video clip. To see the overall impact of your Live set on your system, use Activity Monitor on a Mac or Task Manager on Windows. Should your Live set's processing needs exceed your system's resources, Live's overload indicator to the right of the CPU meter will engage and display the text CPU. When this happens, you may experience unexpected and irregular crackles, pops, and silences when playing back your set. These interferences are called audio dropouts. The CPU overload indicator can be toggled on or off from the meter's drop-down menu. The meter text can either show the average CPU load or the short-term current CPU load. This can be toggled using the CPU meter's drop-down menu. The current CPU readout will typically appear more active than an average CPU readout. To get an overview of which tracks in your Live set are causing the heaviest load on your CPU, you can call up the Performance Impact Meters by clicking on the small C button in the bottom right of the mixer panel in Session View. The overload indicator also lights up with the text disk if Live was not able to access audio files from the disk on time. This again can result in audio dropouts. To avoid this, we recommend storing your sounds on an internal SSD drive, as mechanical hard drives are typically slower and external drives have typically less bandwidth to send data, especially connections slower than USB 3. As a rule of thumb, you should always have at least 10% of your hard drive's capacity available as free space. It's preferable to have as much free disk space available as possible. In Live's preferences, we can change the buffer size using the chooser in the Audio tab. The most common cause of audio dropouts is choosing a buffer size that is too low for your machine to work with under the current conditions of playback. Setting a higher buffer size will often resolve audio issues like dropouts. The consequence of choosing a higher buffer size is the introduction of latency. The higher value you choose, the more you may experience a slight delay when monitoring or recording audio and MIDI. Users often change the buffer size to match their activity, choosing a low value when recording or performing, and choosing a higher value when mixing or producing. The most common optimal buffer size range is between 128 samples and 1024 samples. The sample rate you are using for recording and playback can also have an effect on Live's CPU needs. The sample rate of digital audio refers to the amount of tiny slices of sound that your computer records or plays back per second. We perceive these slices as a continuous stream of audio. You can change live sample rates under the Preferences tab, Audio, using the chooser. The higher you set live sample rate, the more system resources will be needed for recording and playback. Using a high sample rate will not necessarily make your audio sound better. If you take a sample recorded at 48K and ask Live to play back that sound at 96K, the sound won't be improved. However, it will take more system resources for Live to convert the audio and complete the task. A recommendation here is setting the sample rate to at least 44.1K. Ideally, Live's sample rate and your audio file's sample rate match. For example, if you are using samples recorded at 48K, then Live's preferences should also be set to 48K. Bit depth refers to the amount of potential information contained in a sample of digital audio. Recording audio at a high bit depth can allow for a greater amount of detail and dynamic range. However, the resulting file will be larger and require more disk space. Playing back a 32-bit file can therefore demand more bandwidth from your hard drive than playing back a 16-bit file. Navigate to Clip View to see the bit depth and sample rate of any audio clip in your Live sets. To change the bit depth that Live will use when recording audio, navigate to the Record Warp Launch tab of Live's Preferences and use the chooser. Avoid unnecessarily mixing bit depths and sample rates when importing audio samples into your Live set, as Live will have to work harder to convert this media to align with your set's settings. Another feature to be mindful of is Live's high-quality sample rate and pitch conversion. When this feature is enabled in an audio clip, Live uses a more sophisticated algorithm to play back the audio. You can especially hear the benefit of this feature if you transpose the pitch of the audio. If you are not transposing a particular audio clip and its sample rate is the same as your Live set, you may not benefit from having this feature engaged. You can turn this feature on and off in Clip View using the High Q button, and you can toggle this as a default feature in new audio clips by navigating to the Audio tab in Live's Preferences. You can test your audio settings using Live's Test Tone Generator, which can be found in the Preferences under the Audio tab. This feature simulates a chosen percentage of CPU load under your current settings, enabling you to audition changes to your buffer size and sample rate. This is a great way of finding a happy medium between your desired use of Live and your system's capability. Freezing a track or consolidating an audio clip are quick ways to convert audio to the bit depth and sample rate that you are currently working with. The first time you start a version of Live, many processes happen in the background, and you may experience that Live uses more of your computer's resources than normal. This is because, among other things, Live is building a comprehensive real-time directory of all the content referenced in your browser. This process is referred to as indexing. This can also happen after you've added a large file to your browser. The spinning black circle that appears next to the word Places indicates that Live is indexing its browser. Live's browser indexing shows up as a separate process in Activity Monitor on a Mac or Task Manager on Windows, so you can always get an overview of how much processing power indexing is using. The Places section of Live's browser is a great place to add shortcuts to specific files and folders you want to access in Live. But avoid adding large general folders, such as desktop or downloads, which forces Live to sift through more data than is necessary. Also avoid adding entire system drives, such as your C drive. Also be aware that using cloud-based storage for your samples can introduce a layer of complexity to your system that, in some cases, puts extra strain on your computer's CPU. We recommend that you avoid introducing a cloud-based folder containing lots of files into Live's browser. Sometimes your musical ideas are bigger than the tools at your disposal. As you add more and more processing and complexity to your tracks, you may approach the upper limit of your computer's ability to play back your sets. This can result in audio dropouts. Live's main solution to this conundrum is the freeze feature. Freezing a track captures its current state into an audio track, which frees up your computer from the resources it was using. Freezing a track also gives you the option of unfreezing it later, allowing you to stay in the flow and come back to finish tweaking your settings later on. There are a few other things you can do to optimize Live on your system. If you are using many instances of a CPU-heavy effect, consider replacing them with just one instance of the effect on a return track and using sends to access that effect. Disk overloads can be avoided by loading selected audio files into RAM, where your system can access the data very efficiently. This is especially a good idea if you have large files or sampler instruments stored on an external drive. To do this, either engage the RAM button in the clip view of an audio clip, or engage the RAM button in Sampler's Sample tab. Be mindful of unintentionally using oversampling in both native and third-party devices, as this adds to the CPU load when playing back your set. You can enable or disable oversampling in certain native Live devices by calling up the context menu from the device's header. Using the Complex and Complex Pro warp modes can add to your set's CPU load. If you find yourself simultaneously warping many clips using these modes, you may consider consolidating the warped audio if you need to save computer resources. Disable unused inputs and outputs on your audio interface from Live's preferences. Navigate to the Audio tab and open the Input and Output configuration menus. Make sure you are only using one plugin format per set for each individual plugin. Avoid mixing VST, VST3 and AU versions of the same device. We hope that this video will help you optimize your own system so that you can use Live to its fullest potential.